All right, we're going to take a look at shifting functions. So this is something that your pre-calculus classes should have focused a lot on, shifting all types of functions left, right, up, down, stretching them out, all that good stuff. And we are going to be doing a lot of visual problems, but just in general, when you're shifting functions, your input affects your left to right direction. So that x on the inside, we can call that the x direction. That's going to be influencing your shifts to the left and shifts to the right. Whereas any sort of an operation that occurs to the f of x, like kind of on the outside of the function, if you will, that's going to affect your vertical, your y value, kind of like your y direction. So that's where your graph is going to be shifted up and shifted down. Now, you may remember all sorts of examples of, x minus h, where h is your horizontal shift. Add k is your vertical shift. So if I have an example like f of x minus 3, that's a horizontal shift, and it's shifting the graph 3 units to the right. Whereas if I have f of x, and then outside of the f of x operation, I'm subtracting 3, that's your k value. That's a vertical shift. You're moving the graph down 3. So hopefully that kind of rings a bell. But let's actually run through an example with a physical graph, because I'm just trying to align this with some of the summer work that you guys have in front of you, so this should look kind of familiar. So let's say that this is my original function f of x, and I want to add 2 to this function. So I'm taking the function I have established, I'm adding 2 to it. That's pretty simple. I'm shifting it up 2. Let's say that I do f of x plus 2 on the inside of the parentheses. Well, now I'm shifting to the left 2. You can see that I'm translating all of those points 2 units to the left. Now let's talk about reflections. What would cause a graph to reflect? Well, one of the operations you could do is multiplying by a negative on the outside. This would cause a reflection over the x-axis. So you can see I've reflected these points over the x-axis because the y values are all getting multiplied by -1. Let's take a look at a different graph, and we'll try some more transformations and more shifts on this. So let's do a kind of a complex one here. We've got -2, f of x minus 1 plus 2. So the first thing that I want to start off with is the x minus 1, then the -2, then the plus 2 at the end, just following order of operations here. So I'll start off with my x minus 1. That represents a shift to the right by 1 unit. Then I'm going to multiply by -2. So if that value originally had a height of 1, now it's going to have a height of -2. So that's going to shift it down essentially by reflecting it and doubling it. So we're at -2, and then we're going to add 2 at the end. So we're going to shift back up 2 units, which means that that point ends up at that coordinate of -3, 0. So that's kind of the process for all of these points, and to save some time, I'm just going to shift them all at once here for you. And that's what this graph ends up looking like. Now, it might look so dramatically different from the original, but let's just compare so we can kind of see where everything comes from. You see this original slope of 1 here on the far left that I've highlighted in blue? Look what's happened to the slope. The slope has become -2. It's gone down 2 over 1, which makes sense with that -2 out in front. You can see the same thing happen here. We got a shift in green of down 3 over 1. It becomes up 6 over 1. And that little slope at the bottom, which looks like it's down 1 over 1, ends up being up 2 over 1. So you can see all the slopes are being multiplied by a negative, and they're doubling in their value, becoming more steep. So this is a good example of a compound shift here. We've got all the different types of shifts that you could possibly see. I would also say watch out for absolute value. If you take the absolute value of a function, think about what that's going to do to your y values, how that's going to affect them. But hopefully this helps kind of give you a quick overview of shifting functions. I know that this can be a challenging area. Play with your coordinates, actually draw it out the same way that I did with that first point. I think that helps a little bit when you guys get started with these.